Hey guys, we are starting with the chapter Matrices, which is chapter number 3 in your 12th standard textbook, volume number 1. We have learnt about relations and functions, and we are yet to learn inverse trigonometry functions, which will be done after this chapter. We are going to Matrices chapter, where some of you must have learnt in 10th standard syllabus itself. We'll go to matrix. What exactly is a matrix? A matrix, as defined here, is an ordered rectangular array of numbers, and it is telling rectangular array of numbers. What do you mean by array? Array is the arranged arrays in terms of rows and columns or functions. Arranged, this also is important. It may be numbers or it may be any kind of functions. The numbers of the functions are called as the elements of the matrix. So what is a matrix? Let's go for some example. And as in your textbook, they have given this certain example where they say the first row will have 15 and 6 elements, the second row will have 10 and 2, third row will have 13 and 5. So all the elements or the functions which are arranged horizontally will form the rows. So row number 1, row number 2, row number 3. So this is row number 1. And like this, when you take it is row number 2. And this is row number 3, and we are going to indicate like this in our chapter from now on as R1, R2, R3, which is nothing but the first row, second row and the third row. Likewise, all the elements which are arranged vertically, they are said to be the columns. They are the pillars. Okay, you can remember it like this. It is the first column and this is the second column, and we call it as what? C1, C2. And now in a matrix, the rows and the columns are filled up with the elements like this, and these number of elements will give us some certain number of rows and certain number of columns, and that we call it as the order of the matrix, which we'll be studying in the next. Now before going into that, let me give you some example where we use different kind of functions. So what do you mean by those functions? It may be trigonometric functions, it may be complex numbers, it may be irrational functions also. So those elements can be anything. Example, A is equal to, and matrix is always represented by capital alphabets like this, and there are certain brackets that we use. See, the brackets that we use will be, all the elements are enclosed by small brackets like this, or some kind of matrix brackets like this, or it may be with square matrices like this with square brackets, or sometimes it will be double lines on either side. Okay, and the very frequently standardly used is this brackets, as you see here, and it indicates what? Matrix. Matrix is always enclosed by square brackets from now on in our chapter, or else these are also brackets which you can find in some of the question papers in the textbooks. And coming back to the example that we were discussing, every matrix is denoted by the capital alphabet. A equal to, I am taking now here, it may be A, B, C, D, anything as such, and the elements may be like this: cos theta, minus sin theta, cos theta. This is a matrix which has row number 1 with these elements, row number 2, and this is column number 1, and this is column number 2. It has 2 rows, so it is 2 rows cross 2 columns, it is 2 cross 2. And the way when I write this 2 cross 2, this is called as the order of the matrix. It's called as the order of the matrix. So this is the way we use matrix, and these matrices are used anywhere and everywhere you see in your daily life, children. See, matrices, if you want to put number of hours, the timetable what you use in your school is also a matrix method, is it not? So it is used in the matrix. Number of days and number of tests conducted, the report card what is given to you is also in matrix. So anything and everything that you make the tabular columns will give us matrices. Okay, so these matrices can be of any number of rows and any number of columns, and that number of columns, what we say, we call it as order of the matrix. And when we take this these examples, I told you these are all the elements inside the matrix. See, suppose I say B is equal to root 2 minus 1, 3 plus I minus I plus 1, and here I'll say root 3 minus 1. See, I have mixed up complex numbers and irrational numbers. You can use certs, anything can be the elements inside a matrix. And let me use one more order here, so the order becomes different. 0, I'll say 0, 0, 0, 0, 1. Okay, now what you have? You have 3 rows. You have 3 rows and 3 columns. I'll take one more, 1, 2, minus 1. So this is also a matrix where you have how many rows? Row number 1, row number 2, row number 3. So it has 3 rows cross. How many columns does it have? It has 4 columns, so it is 3 cross 4. Or we also tell it as 3 by 4. Now this is about the matrix. So let us go to the types of matrices, or the general way of the matrix. First we write how we denote a matrix in general. So we go to the next. See, this is about order of a matrix. A matrix having m rows and n columns is called a matrix of order m cross n. So the standardly in a matrix we always take it as m number of rows and n number of columns. So this is the way we write the general form of a matrix. So I shall show you general form of a matrix. How do you write? If it is not exactly the numbers, what do you call? So when I take a matrix 1, 2, minus 1, 0, 1, 1, minus 1, 3, 2, something like this. Say this is the element present in first row and first column. So it is nothing but A11. So A11 is the place where 1 is present. A11 is equal to 1. Then what is this here? Where is this? This is in row number 3 and it is column number 2. So I write A32. This is A3, third row, second column. So A32 is equal to 3. So the element present in third row, second column is 3. So then where is your minus 1? Minus 1 is third row, first column, which is equal to A31, and that's equal to minus 1. So now if you write, if it is in ith row and jth column, we write it as Aij. So similarly, so if I say Aij, what is that? This is nothing but element present in ith row and jth column. Okay, jth column. Okay, now so let us write the general form. When I use I and j, how is it going to be looking at? It's like this. I'll go to first row A11, first row second column A12, first row third column element is A13, and so on. How many number of rows I am going to take? I am going to take m number of rows. There's a standard letter that we use for number of rows. So I shall go till A1, number of columns is n, so A1n. The first row and n number of columns, so A1n. Now like this I am going till mth row. I start second row first column element, second row second column element, A2, 3 and so on till A to n. Like this I shall go to some ith row, AI1, AI2, AI3 and going on. I will have some general element which is present in ith row and some jth column. This calls general element and so on. This will end up with AIN. Now like this I will go to mth row, that will be AM1, AM2 and so on. The last element of course will be AMN. So now this is enclosed in square brackets. We call this as the matrix A equal to having m number of rows and n number of columns. So its order will be m cross n. And what is Aij? As we saw, this is called as the general element present in ith row and jth column. So I explained what is Aij. So when I ask you what is the place of that number, you should be able to tell what is the order and the column which is present in. That is denoted as Aij. And with this, let's go to the types of matrices. and also the construction of the matrices. If I give you what is Aij, you should be able to construct the matrix also. So even before I go to the types of matrices, let me tell you construction of matrix, and this forms like sometimes only 1 mark question in your PU board question paper. So you should know to construct the matrix. Construct a matrix. Construct the matrix, I'll write, and I shall take the first example like this. I will define you what is Aij. Aij is equal to half of modulus of say I minus j square, I'll say. Okay, anything can be given like this, I minus j square. Okay, and now I want a 2 cross 3 matrix. Okay, what do you mean by 2 cross 3 matrix? It should have 2 rows and 3 columns, and it is defined, Aij is defined to be like this. What do you mean by I and j? I and j is the indication of the row number and the column number. So if I want A11, then I'll put I is equal to 1 and j is equal to 1. So let us start 2 cross 3 matrix construction. A is equal to 2 rows, A11, A21. I reach the 2 rows, I'll stop there, and I should end up with the third column. So A12, A13. Continuing here in the second row, it will be A23. See, I've ended with 2, 3. I got a 2 cross 3 matrix, and now for this, how do I construct the matrix? How do I get my elements? It is because of this definition. So I'll go there. What is A11? A11 will be equal to half of modulus of I is 1 minus j square is 1, which is equal to 0. So the first element is 0. Next I go to A12. A12 is equal to half into 1 minus 2 square. I'll put j is equal to 2. 2 square is 4. You got 1 minus 4. But 1 minus 4 is minus 3. But modulus of minus 3 is plus 3. So you got 3 by 2. So my next element is 3 by 2. So what is A13? A13 will be equal to half of modulus of I is 1 minus 3 square is 9, which is equal to 4, right? 1 minus 9 is minus 8. Minus 8 modulus is plus 8. 8 by 2 is 4. And I got the next element as 4. And the next one, A21. A21 will be half of modulus of 2 minus 1 square. 2 minus 1 is 1, so it's equal to 1 by 2. Likewise, next I'll go to A22, which will be half of modulus of 2 minus 2 square is 4. 2 minus 4 is minus 2. 2 by 2 is 1. And then A23, the last element will be half of I is equal to 2, j is equal to 3. So 2 minus 3 square is 9. 2 minus 9 is minus 7, but modulus of minus 7 is plus 7, and I got 7 by 2. I shall fill up all the elements now. I'll go there. 2, 1, 2, 2, 2, 3. Elements are 1, 2, 1 by 2, 1, 7 by 2. So it is 1 by 2, 1, 7 by 2. I got my matrix. So whatever the matrix order they say, once you know the definition, you should be able to construct the matrix with replacing your I and j with the corresponding numbers of the row number and the column number. You will get your matrix. And like this, a construction of matrices can be possible with any order once the definition is given. Now we go to types of matrices. And now I will be particularly telling you that when it comes to types of matrices definitions, that is also one of the compulsory questions that you have in PU board question paper. Definition is supposed to be very accurate. See, suppose I tell you, after the definitions I can tell you some example. Beforehand I will tell you, suppose you have not taken the word square. A matrix definition should have that word square, then only we are supposed to give you 1 mark. If that is so, if you have not written square but the entire definition is there other than that word, then you will not get your 1 mark. So definition should be very appropriate, and to be on the safer side, it's always better you understand, but please write the same definition what you have in your NCERT text. And these are all the definitions which we have taken out from the textbook itself, so that it will be accurate. Okay, so now I have types of matrices. First matrix, that is column matrix. The name itself tells you that column matrix is a matrix which will have exactly 1 column. If it will have exactly 1 column. And when the operations towards this matrices come out, especially in multiplication of matrices, order takes an important role. You should be very careful what is order. What will be the order of the outcoming matrix after multiplication. In that particular concept, this row matrix and column matrix is very important. Okay, coming to column matrix, example of column matrix I am writing. It should have only one column, that is vertical elements. Okay, elements present in the vertical line. So now this will be minus 2, 3, 4, 5, something like this I give you. Now what is the order of this matrix? It is always having one column, so n will be 1 itself always, and it can have any number of rows. Here what is the rows? 1, 2, 3, 4. This is a 4 cross 1 matrix. I shall go for another matrix example. B is equal to minus 4, 3, 0. Now what is this? This is 3 cross 1. And every time you can say, because it is having exactly one column, but it can have any number of rows, order of this column matrix, order will always be equal to m, but only one column, m cross 1. Likewise, the vice versa, row matrix will always have the order. So what is order of row matrix is equal to, it will have exactly one row, but it can have any number of columns, and so we retain that n as it is number of columns. So what is the order of what is the row matrix example? If I write the same thing horizontally, I will get the corresponding row matrix minus 2, 3, 4, 5. If I say this will become only one row, but it will have 1, 2, 3, 4. It will become 1 cross 4. And now writing this, the column as the row, it is said to be the transpose of a matrix, which will be talking later on. Similarly, here if I say B equal to, I shall write a different example. It will be like 0, minus 1, 2, 4, 5. Okay. Now what is the order of this matrix? Only one row is there, but how many columns? 1, 2, 3, 4, 5. It is 1 cross 5. So we wrote the order of the row matrix as 1 cross n. And then next we come to zero matrix. What do you mean by zero matrix? Once again, the name itself it tells you all the elements will be equal to 0. We should not say all the elements are zeros. No. Every element is equal to 0. So a matrix is said to be a zero matrix, or it is also called as null matrix, or it is also called as void matrix if all its elements are equal to 0, are 0. We generally write are equal to 0. Okay. So now what do you mean by the zero matrix order? What do you mean by order of the zero matrix? It can be anything. So zero matrix order will say, and it is denoted by, zero matrix is always denoted by capital O. Okay. So O is equal to, see, 0, 0, 0, 0, and I should stop here. Now what is the order of this zero matrix? All the elements are equal to 0. So it has 2 rows and 4 columns. So it is 2 cross 4 null matrix. Now one more I will write. O is equal to 0, 0, 0, 0, 0, 0, 0, 0, 0. We call this as a 3 cross 3 null matrix, or it is also called as third order null matrix. We see it is third order null matrix. Whenever you have number of rows and number of columns equal, we get the same number, is it not? 3 cross 3. So it is said to be a third order null matrix. So we will be coming across the square matrix also. And now going to the next one, rectangular matrix. See, we all over I have discussed about rectangular matrix only in the same exam. So these are all the same examples we have. See, number of rows and number of columns are all different here. Everything looks like a rectangle. There is no square over here. These are all called as the rectangular matrices. So what is rectangular matrix? Where number of rows is not equal to number of columns. A matrix in which the number of rows are not equal to the number of columns are said to be rectangular matrices. And we have discussed about rectangular matrices till now. And now we are going to square matrix, and the next part of the definitions are very, very important. Yeah, here we have the next types of matrices. We have square matrices, square matrix, and then the diagonal matrix, scalar, and identity. Now these definitions, these 4 definitions are very, very important for 1 marker. You may get the definition and it has to be very accurate. And now one thing, we have taken all these together because from square matrix you get diagonal matrix, from diagonal matrix you get the scalar matrix, and from scalar matrix you get the identity matrix. They are all related to each other. And so Okay, after the explanation, I'll tell you one more sentence, one important one. Let's go to square matrix. Now, what do you mean by square matrix? We have already discussed about it. When number of rows will be equal to number of columns, it is said to be a square matrix. And that word square is very important from now on when we discuss about the definitions. So, square matrix, I shall take A is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9. This is a third order square matrix. This is a third order square matrix. I shall take B is equal to 1 minus 1 0 1. This is a 2 cross 2 matrix, so it is said to be second order row matrix. Second order square matrix. And now we'll go to diagonal matrix, which will be coming from the square matrix. So I shall go to next one. C is equal to diagonal matrix. I'll write first the example and then we'll go to the definition. See, in diagonal matrix, the diagonal will be non-zero elements and the rest all will be equal to 0. This is called as a diagonal matrix, and still it is always available. This diagonal matrix is always available only for a square matrix. And now let me discuss about something called as principal diagonal. In a square matrix only in a square matrix I get what is called as a principal diagonal. So here also the square matrix, the principal diagonal elements are what? 1, 5, 9. This is said to be the principal diagonal. The spelling is important. It is the principal diagonal. Diagonal. Okay. And in the principal, from now on principal diagonal, I am going to call it as PD elements. So I shall write these are the PD elements. Okay. Principal diagonal elements will be non-zero elements. The rest all elements will be equal to 0. Then it is called as a diagonal matrix. How are you going to write the definition? A square matrix, the word square there is important. A square matrix is said to be a diagonal matrix if all its non-diagonal elements are 0. See, all the non-diagonal elements will be 0 and the diagonal elements will be non-zero elements. It will not be equal to 0. It may be anything. So this is called as a diagonal matrix. So we can also say, my statement you observe now, you listen properly. Every diagonal matrix is a square matrix. Every square matrix cannot become a diagonal matrix, but every diagonal matrix is always a square matrix. So that is why this word square is very important. And the diagonal will be available only in a square matrix. That is why you have to mention the word square. And let's go to the next one. D equal to, we are coming to scalar matrix. The word scalar means constant. Is it not? It is equal to a constant, or which will have only a magnitude, it will not have a direction, is called a scalar in the quantity. Is it not? It's called as a scalar quantity in your physics. Now in mathematics, scalar means it's always one constant. Okay, it's always one constant. So constant matrix, we don't say constant matrix, we say scalar. From the diagonal matrix we get the scalar matrix. So I can say scalar is nothing but a diagonal matrix in which all these PD elements will be equal. So I shall take 2, 2, 2. The rest all will be elements will be equal to 0. So this is called as a scalar matrix. So every scalar matrix is a diagonal matrix, and every diagonal matrix is a square matrix. It will go upwards. Now coming back, I go to the next type of matrix, which is called as the identity matrix, and very, very crucial matrix in all our operations. So we have identity matrix is always given by I. Identity matrix is always given by I. It is indicated by I, and once again it is a square matrix in which elements in the diagonal are all equal to 1 and the rest elements are all equal to 0. Then it is called as an identity matrix. Now see, the identity matrix can also be defined like this. Identity matrix is the diagonal matrix in which all the PD elements are equal to 1. So 1, 1, 1. If you are using your own sentences, be particular about the kind of words and the English you are using. Let the sentences be proper. So identity matrix is a is a diagonal matrix in which all the PD elements, principal diagonal elements are equal to 1 and the rest elements are all equal to 0. This is the identity matrix. Now identity matrix, this also is a third order identity matrix. I can also write I is equal to 1 0 0 1, which is a second order identity matrix, or I can write a fourth order also 1 0 0 0 1 0 0 0 0 1 0 0 0 0 1. This is a fourth order identity matrix and so on. So order of identity matrix, if I say first order, correspondingly in the problems whichever they give the order, you have to take the corresponding ordered identity matrix. Now these were the types of matrices, and okay, children, and here goes the from slowly we are getting into the operations of the matrices. Even before getting into the operations, we have something called as equality of matrices. Suppose I say one matrix is equal to the other matrix, the corresponding elements in the places will be, they'll be equal. The two matrices A is equal to Aij, B is equal to Bij are said to be equal if they are first of all of the same order. That's one very important point. They have to be of the same order. 2 cross 3 will be always be equal to only a 2 cross 3 matrix, and then each element of A is equal to the corresponding element of B. Okay, or Aij will be equal to Bij. Aij is the general element of the matrix A and Bij is the general element of the matrix B. So if I say A23, it should be equal to B23. Then only we say those matrices are equal. And so now we have an example here. Find the values of this. Of course, this also is from your textbook. Find the values of A, B, C and D from the following equation. Now because they say equation and the two matrices have already been equated, I can take the corresponding elements equal to. So I shall take, you have 2A plus B is equal to 4, they say. I got one equation. And the next one I'll take, you have A minus 2B is equal to, A minus 2B is equated to its corresponding place, the place in the other matrix is equal to minus 3. And then you have 5C minus D. 5C minus D is equal to 11, and then you have 4C plus 3D is equal to 24. Now we see that you have been given equations and you are supposed to find out A and B value. So it is very simple that we solve them simultaneously to get A, B and C, D values. 2A plus B is equal to 4. I shall multiply this equation by 2 or this by 2. That will be better. So this gives you, solving them simultaneously, I am getting 4A plus 2B is equal to 8. A minus 2B is equal to minus 3. Plus 2B minus 2B got cancelled, and you got 5A is equal to 8 minus 3 is 5, and you got A is equal to 1. Once I get A is equal to 1, I can go substitute and find out what is the value of B. So I'll go back to the same equation here. I'll call this as equation number 1. So equation number 1, I'll go and substitute A is equal to 1. That will be 2 into 1 plus B is equal to 4. That gives you B is equal to 4 minus 2, which is equal to 2. And similarly, I am going to solve the other two equations. 5C minus D you have, and here you have 4C plus 3D. So I shall multiply this by 3. That gives me 15C minus 3D is equal to 33. Under this I am going to take this to solve them simultaneously. 4C plus 3D is equal to 24. So 3D and 3D gets cancelled. 15 minus 4 will be equal to 11C, and this is equal to 3 minus 4 is 1, 3 minus 2. So you got C is equal to 1. Oh, I have subtracted, which means that I have done wrong. 15 plus 4 is equal to 19C. 19C is equal to, it is 57. So C is equal to 3. And after I get C equal to 3, I am going back to one of the equations. Let me call this as my equation number 2. Equation number 2 implies 5 into 3 minus D is equal to 11. So 5 3s are, it will be 15. 15 minus 11 is equal to D. So D is equal to 4. So from solving all this simultaneously, I have got A is equal to 1, B is equal to 2, C is equal to 3 and D is equal to 4. So we have learnt one kind of operation, not exactly operation. Equality of matrices is what? Okay, now after this equality of matrices, we'll go to some kinds of problems where we can where different kinds of questions can be asked about the basics of these matrices. Okay, here goes your exercise 3.1 question number 1. The order of the matrix, the number of the elements and the elements which are present in A1, 3, 2, 1, 3, 3, 2, 4 and 2, 3 are to be written. A very simple question where you have to only understand the physical nature of that matrix. Let's come. Order of the matrix. How many rows are there? There are, so I'll go to the first question. Order. How many rows are there? There are 3 rows. And how many columns are there? 1, 2, 3, 4. There are 4 columns. So this implies order of A is equal to 3 by 4 or it is 3 cross 4. And I'll go to the second sub question. In the second sub question, what is that they're asking? How many elements are there? Number of elements. Number of elements, I don't want you to count there. Instead, we are going to just multiply the order. We get our number of elements. 3 into 4 will be giving you 12 elements. So, are there 12 elements there? 4 in the first row, next row 4 and next row 4. So, 3 into 4. And then we go to third sub question there. They want us to write what is A13 equal to A21, A33, A24 and A23. So these are nothing but the elements present in that particular row and that particular column. I go to A13. A13 means the element present in the first row and the third column. First row, third column will be 19 in the matrix. Is it not? So then A21. A21 is second row, first column. The second row and the first column. Intersection point will be 35. So it is 35. Second row, first column. Third row, third column. This is the third row and this is the third column. So the intersection point in that particular point, the number found to be is -5. And the next A24, second row and fourth column, that's going to be 12. What is A23? Second row, third column, that is 5 by 2. Okay, so I am sure that now you have understood what is the meaning of the name of the place that we write for the elements and we give to them. We go to the next question. Okay, here goes the next question. If a matrix has 24 elements, they have given number of elements. Number of elements given to be is 24. What is that you want? What are the possible orders it can have? What if it has 13 elements? So this is the first part of the problem. I'll call it as A. Number of elements is 24. What are all orders can you have using 24? It is just like this. If I give you 24 things, in what all ways you can arrange them? It may be only in one row, it may be only in one column, or it may be in 2 rows, or it may be in 3 rows and so on. So it's very simple, just that take the factors. Number of elements, possible orders are. Possible orders are, it is like this. It may have only one row, so 1 cross 24, or it may have only one column, so it is 24 cross 1. And then I'll go for 2 rows. If I say 2, I can arrange 12 elements in 2 rows. In each row, so 12 2s are 24. So I'm taking from one multiple. 1 into 24 is 24, 2 into 12 is 24, and immediately write the vice versa of that so that you don't miss any order. 12 cross 2 also is possible. And then from 3 8s are 24, 3 cross 8, and immediately I'll write 8 cross 3. Is it possible by 4? Yes. 24 is divisible by 4 also. 4 6 are 24. So I say it is 4 cross 6, 6 cross 4. Okay, what about 5? No. What about 6? That has already been written. So 6, 8, 12, 24, it's already been written. So how many possible matrices are possible when I give you orders are possible when I give you 24 elements? 1, 2, 3, 4, 5, 6. There are 8 different ways of arranging the elements. Using all the elements, of course. Now we'll go to the second part of the problem. When you have 13, you have been given 13 elements. So if you are given 13 elements, how many possible orders are there? So the possible orders are, it will be 1 cross 13 or it will be 13 cross 1, because 13 elements cannot be equally distributed in 2 rows or 3 rows and so on. And the other way of telling is 13 is a prime number. It has only 2 factors, 1 and itself. So it is possible only in these 2 ways. The arrangement is possible only in 2 ways. And again, we'll go to the next question again. Yeah, here goes the construction of matrix question, and we have already learnt about the construction of matrices. I have taken 2 examples where you have one with modulus, the other one with a very simple one, and they want a 3 cross 4 matrix. Okay, so I am going to do the first one. You have been given the definition Aij is equal to half of modulus of minus 3i plus j. So I want A 3 cross 4, is it not? So A is equal to 3 rows I want. So I say A11, A21, A31. I reach the third row, I'll stop there. Now I have to reach the fourth column. So until I get 4 here, I'm going to write A11, A12, A13, A14, A22, A23, A24, A32, A33, A34 is equal to, let us calculate as we did in the example what we saw, 1 and 1. I am going to put 1 and 1 here. Minus 3 plus 1 is minus 2, divided by 2 is going to be 1. And always remember, whenever they give you modulus, none of your answers is going to have negative sign. So keep it in mind, modulus, even by mistake or hastily, you are not going to write any minus over there. So here minus 3 plus 1 is going to be minus 2, but modulus of minus 2 is plus 2. 2 by 2 is 1. Next I go to A12, I is equal to 1 and j is equal to 2. So minus 3 plus 2 is minus 1. So the next one is going to be 1 by 2. A13, I is equal to 1 and j is equal to 3. Minus 3 plus 3 is going to be 0. 0 divided by anything is 0. So it is 0. 1 and 4. Minus 3 plus 4 is 4 minus 3 is 1. So it's again going to be 1 by 2. And then A21, I is equal to 2. So this will be minus 6 plus 1. Minus 6 plus 1 is minus 5. Modulus is 5. So this will be 5 by 2. 2, 2. Minus 6 plus 2. Minus 6 plus 2 will be minus 4. And minus 4 modulus is plus 4. 4 by 2 is 2. And the next 2 and 3. Minus 6 plus 3. Minus 6 plus 3 is 3. So this is going to be 3 by 2. 2 and 4 minus 6 plus 4 is going to be 2 by 2 is 1. And then 3 and 1 minus 9. Minus 9 plus 1 is 8. 8 by 2 is 4. 3 and 2 minus 9. Minus 9 plus 2 will be 7. So this is 7 by 2. And this is minus 9 plus 3. Minus 9 plus 3 will be 6. And so this will be again 3 by 2. No, one moment. This will be 3 and 3, is it not? Minus 9 plus 6. Minus 9 plus 3. Minus 9 plus 3 is minus 6. 6 by 2. This is going to be only 3. And did we do properly here? I just want to check out. So this is minus 6. Minus 6 plus 3 is minus 3. Yeah, this is 3 by 2. Okay, correct. And then I come to 3 and 4. Minus 9 plus 4, it will be 5. So this is going to be 5 by 2. I got my matrix. And even by chance, you are not going to write this line. Now this is a matrix. This is the denotion of the matrix sign. But whereas when I write only simple one line, this is going to be something called as determinant, which will be used in the next chapter. So even by chance, when you are writing the brackets, you cannot write single line like this, because that denotes determinant. This has to be a square matrix. So many times in the problems, in the usage of brackets, if something goes wrong, though you have done everything, if every part of your problem is correct, the usage of brackets may give you 0 marks. Wrong brackets. Okay, now this was about the first problem. I'll come to the second problem. Second sub question tells you Aij with the definition 2i minus j, and once again they want 3 cross 4. I shall keep this itself as my basic one with the general elements, and I shall calculate. So A11 2 minus 1 1, A12 2 minus 2 0, A13 2 minus 3 is minus 1, and 2 minus 4 is minus 2. Next I'll take 2 1, 2 2s are 4 minus 1 3, 2 2s are 2 2s are 4 minus 2 is 2, and this is 4 minus 3 is 1, 4 minus 4 is 0. Next I shall go to 3. Now 3 and 1, 3, 2 3s are 6 minus 1 5, and then 6 minus 2 is 4, and then 6 minus 6 is, no, I think something went wrong here. I shall do 3 and 2, right? 2 3s are 6 minus 2 is 4, and then 3 and 3, 2 3s are 6 minus 3 is 3, 3 and 4, 3 2 3s are 6 minus 4 is 2. Okay, 5 4 3 2. Now this is our answer for Aij when it is defined as 2i minus j. So here you see, whenever you have modulus, there is not going to be any negative sign inside your matrix. When no modulus is given, you should be careful with your plus and minus over here. This is about construction of matrices. Okay, here goes the next question where we need to find out the values of x, y and z from the equations. There are 3 sub questions, and they are very simple. I go to the first sub question where they say 4 3x5 is equal to yz15. Whenever this equality sign is given to you and you are asked to find out some unknown values, even if some addition and subtraction is given, you should be able to do the corresponding addition and multiplication directly without doing actual addition and multiplication. So develop that right from now. As such, there is no addition and subtraction operation here. We are going to just equate the corresponding elements. So we have x is equal to 1, and then y is equal to the corresponding element 4, and then z is equal to 3. Z is equal to 3. So we are done with the first one, and we go to the next question, that is the second sub question where they say x plus y2 5 plus z xy is equal to 6 2 5 8. Okay, I shall take the first one. You have x plus y is equal to 6, and the next one I shall take 5 plus z. 5 plus z is equal to 5. Immediately you got z is equal to 0. I am done with my z value. But what about the other one? X plus y is equal to 6. I shall say y is equal to 6 minus x, and I shall use this in the next one. Xy corresponding element will be 8. They have given xy is equal to 8. So I shall substitute y is equal to 6 minus x. 6 minus x is equal to 8. Take x inside. You have got minus x square plus 6x minus 8 equal to 0. Or this is also x square minus 6x plus 8 equal to 0. Factorizing, you are getting x minus 4 into x minus 2 equal to 0. So I got x is equal to 2 comma 4. Am I right? Minus 4 minus 2 gives you minus 6. Minus 4 into minus 2 is giving you plus 8. I've got 2 values of x, so I should get 2 values of y because they are related. See, the relation is here. What is y equal to? 6 minus x. So when x is equal to 2, let me call this as equation number 1. Equation number 1 implies y is equal to, I'll plug in x is equal to 2, 6 minus 2 is 4, and I shall plug x is equal to 4, 6 minus 4 will be 2. So therefore, the answer, you have 2 answers. So solution for this, you have 2 solutions. One solution is x equal to 2, then y will be equal to 4, and z is already equal to 0. Similarly, the second solution will be when x is equal to 4, y is equal to 2, and z is obviously equal to 0 once again. And we go to the next one. The next one is like, it's very nice. X plus y plus z is equal to x plus y plus z is equal to 9, and equating the second and second, you get x plus z is equal to 5, and you have y plus z is equal to 7. Now I shall use x plus z is equal to 5. So x plus z will be equal to 5, but you have plus y is equal to 9. So that fetches you y. Y is equal to 4. I got my y value. Okay, and now I'll go. I'll also put y plus z is equal to 7 here. So I shall I'll take the equation once again. X plus y plus z is equal to 9. Y plus z can be written as what? Y plus z is equal to 7. So I shall say this as 7. So x is equal to 9 minus 7, and that's equal to 2. I got my x value. So when I put y is equal to 4 here, I shall get, so I know y is equal to, y plus z is equal to 7. I shall plug in y is equal to 4. 4 plus z is equal to 7 implies z is equal to 7 minus 4, 3. So what is the solution? Your solution is x is equal to 2, y is equal to 4, z is equal to 3. Please highlight your answers always. The presentation is very important when it comes to the board examinations. The evaluator should not find any mistake to take out any marks for you. So present your answer very neatly and write it compactly, and also highlight your answer so that as they look at the answer, they'll be able to allot the marks for you. The correction also will be, evaluation also will be very faster. And after this, let's go to one another problem to find out some values like this. Okay, here goes the next question where we have to find out the value of A, B, C, D from this equation. Again, they are a bit intricate. They have given equations so that we have to solve them simultaneously to get the values of A, B, C, D. Let's corresponding, we'll equate the corresponding elements. A minus B will be equal to minus 1. So you have A minus B is equal to minus 1. There is one another equation with A and B, that is the A to two elements which are equal. That is A 2A minus B is equal to 0. I shall change the sign. Minus b plus b will get cancelled. 1 minus 2a is minus a is equal to minus 1 minus 0 is minus 1. A is equal to 1. A is equal to 1. And then I go to the next one. You have equation with A and C, and because, okay, I should have found out B also, is it not? So I shall go to this equation. We have A minus B is equal to minus 1. A I'll plug in minus 1 minus B is equal to minus 1. Minus 1 plus 1 is 0, which is equal to B. Minus and minus 1 is gone, so you got 0 is equal to B, or B equal to 0. And similarly, if I go to the next question, next equation, I have A and C. I have a combination of A and C there. So if I go to A to 2 element, 2A plus C, the corresponding element is 5. And I shall plug in A value. A value is 1. So it is 2 into 1 plus C is equal to 5. C is equal to 3. Okay, and we have another equation where you have the combination of C and D. 3C plus D will be equal to 13. 3C plus D is equal to 13. So 3 into 3, that will be 9 plus D, which is equal to 13, and D is equal to 4. So we got B as 0. Let me check with B once again. I'm doubtful. You got A is equal to 1. Okay, A. I of course have done something wrong over here. I shall redo this. You have A minus B. A minus B is equal to minus 1. A is 1 and I had put minus 1. So it is 1 minus B is equal to minus 1. So 2 is equal to B. Yeah. A is equal to 1, B is equal to 2, C is equal to 3, and D is equal to 4. Now this is the way we are going to use matrices, where the relationship between the elements of two matrices are equated, the corresponding elements are equated to find out the values. And we shall, next class we are going to discuss about the operations on matrices, that is addition and its properties, multiplication and the properties under the multiplication of matrices, etc. These are all the very basic. We will meet in the next class once again.